Welcome back, everyone. So, we're doing a part two on the audio amplifier project I did something like 2 years ago, a little less than 2 years. Now, if you remember, what I ended up leaving off on is we got everything out of the TV, built the circuit, got it working, and then I ended up finding out that one of the speakers wasn't outputting barely anything compared to the other one. So, for the part two, we were going to diagnose why and see if we can fix it or if it's internal to the amp. So when I first took this thing out of storage and was getting all set up, I went to test it and it wasn't working, and I'm like, oh no, what happened? Well, for some reason, I never fixed the ground issue that we left off on. So that's why the jumper is installed right now. So as you can hear, it's working. Still only coming out of one speaker, ever so faintly coming out of this speaker. So as you can see on the portoscope here, we are getting a pretty good signal on one of our channels. Very good, actually, once the bass kicks in. Now, on the other channel, you can see that there is something going on. We take it off. It's not just interference. There is some form of signal getting through, but it's unbelievably diminished compared to the channel that you're hearing. So first thing I want to do is take a look at our inputs, and you can see that one channel input's fine. Take the other one. Oh, and the other input's fine. Okay, so the problem has to be from the amp out to the speaker, because everything from the music player into the amp is working. And just to prove that, here's the front of the cap, here's the back of the cap, so the signal's getting through. Same thing on the other channel, front of the cap, back of the cap. Then let's jump to the other side and look at the output of the amplifier. Oh, there's our dead channel. Interesting. So just to prove it, yep, there's our live channel. So this is coming straight out of the amp. Now remember, we just measured the input to the amp. Both channels are fine, but the output, this one, ain't doing so hot. So, what does that mean? Well, so something between the amplifier itself and the speaker's ground is bringing down this circuit. It's almost like there's a short. Either the amplifier itself is burnt out on the inside and not amplifying, or maybe the capacitor is cooked. Maybe the path back to ground isn't very good. It's pretty straightforward. It's nothing but a lead going to a capacitor, and then a lead from the other side of the capacitor to the speaker, and a lead from the speaker to ground. So right off the bat, one thing, all these grounds are tied together. So if one speaker's working, the grounds are good. Barring, of course, a damaged wire in between one speaker and the unified ground, but obviously these wires are fine. So we can rule that out, which means now I'm basically down to the leads between the output of the amplifier, this capacitor, and the leads to the speaker. And just like the ground, the leads to the speaker are in great condition. Already checked the solder joints. So really, we're only left with the capacitor. There's nothing left. It's either something internal to the amp or this capacitor. So for posterity's sake, let's just double check now. Seems like the capacitor on the left is working totally fine, and the one on the right is the circuit that is wildly diminished. This is the capacitor we're going to go after. While we're in here, I'm going to fix that problem with bonding the input and the output grounds together. Well, it's time for me to break some bad news. Got the ground wire fixed, got the new capacitor in, everything's hooked back up. And as you can see here, we still have a dead channel. So now just to show, when we hook them up to the same channel, you can see that this probe is properly attached and everything's reading correct. It's just that when we measure the output of our dead channel, it's pretty much dead. And the interesting thing, you can see the output is bouncing around, but it's a 0.2, 0.3 volts on the output of the good channel, and pretty much nothing on the bad channel. But if you check out DC voltage, there's almost 5 volts on our dead channel. So I have tried a few other things to see if I could rescue this. I tried shorting the main grounds on the speakers together, and tried jumping a different couple ground paths in here to make sure that there was no other problems, measured resistance in all the different wires and jumper points on the board to make sure that none of those were open or shorted, even though visually everything looks fine. I just wanted to be certain, and I'm not going to waste another 5 minutes showing you guys a bunch of tests that just continuously point in the same direction. The problem is internal to the amplifier. So what do we do now? Well, we could turn it into a mono amplifier and join the left and the right on the input and just use the one channel that this amp has. But, you know, that's pretty much useless for me. So, as much as it pains me to do it, I just don't think I have anything useful that I can do with this. So the first thing to do is scavenge all the useful parts off of it. Then next, I still have all the parts from that old TV set. So there's plenty more projects to be had just from that one TV. But in particular, while we're on the subject of audio amplifiers, these right here, which drive the deflection coils, these are both amplifiers, and they have something like 16 channels each, or maybe combined, actually 16 channels combined. But these, as mentioned in the last video in the comments by Superbrain, these should be able to be used to amplify audio signals as well. The only thing that might be a problem is if the filtering is done internal, then this might have some filtering that'll block part of the audio signals, but it's worth a shot. So sadly, it looks like that's it for our little audio amplifier that couldn't. I guess it could, but only 50%. Not good enough for me. So, join us in another year when I do part 3 and we test out those deflection coil drivers. See you next time. Another thing I've been working on is looking at the delay between shifting from 3rd to 4th gear. Because as several people have mentioned, you're technically in 2nd for a little while. And I wanted to show that it's an insignificant amount of time, so I hooked up the oscilloscope and I deliberately shifted from 3rd to 4th very slow. And as you can see, the difference, or the time spent in 2nd, is 30 milliseconds.